Okay, we'll start now. So this is about calorific value, right? Just determine the calorific value. So first you have to know what is calorific value, right? What do you mean by that, right? Then we can, there's a way, there's apparatus to calculate the calorific value. It is mm, energy, right? It is an energy, form of energy, right? That there will be a chemical energy inside every fuel, right? When it is burning fuel, that energy, the chemical energy will be converted into the heat energy, thermal energy, right? That is happening when the fuel is burning inside the engine or anything, anywhere, right? So we should know before burning the fuel, we should know how much energy, right? How much energy it has, right? Has for per kilogram or something, right? For if we take some amount of fuel, we should know how much energy when we burn this fuel, how much energy we can get, right? So that is calorific value. That is a simple understanding of calorific value. Just you can say it as calorific value is the amount of energy released or produced when 1 kilogram of fuel burns, right? We are saying take 1 unit, it has 1 kilogram, right? Fuel. Then we are measuring, when we are measuring by burning or something, we are measuring and calculating how much energy is produced, right? When we burn 1 kilogram. So that will be the calorific value of the fuel, right? So that calorific value unit will be kilojoule or joule per kilogram or megajoule per kilogram. It doesn't matter, but we will calculate per kilogram. So 1 kilogram that fuel have this much kilojoule energy, right? That cow dung cake or wood, coal, petrol, right? If you take wood, if we burn 1 kilogram wood, then that wood will be produced around 117,000 to 22,000 kilojoule per kilogram, kilojoule, right? If we burn 1 kilogram wood, we will get approximately between 17,000 to 22,000 heat energy, right? That energy is um, uh, inside the wood as chemical energy, right? The wood contain those energy as chemical energy. When we burn, it will convert it into heat energy, right? Or thermal energy, right? So every fuel have that different calorific value, right? If you take petrol, it is 45,000 kilojoule per kilogram. If you burn 1 kilogram petrol, we will get 45,000 kilojoule energy, right? This is calorific value, right? So, but we can't use every that 45,000 because it is depend on the efficiency of our engine, right? But when we burn 1 kilogram fuel petrol, we will that when we burn the 1 kilogram petrol, that petrol will burning that fuel will produce 48,000 heat energy, right? We can convert 100% those energy into mechanical energy, so there will be loss. But we can we should know, right, how much energy it has, right? Then only we can use for the different application, right? Kerosene also same, 45,000 kilojoule per kilogram. Diesel 45,000, and methane 50,000, right? CNG, LPG, right? Which is we use in our homes, right? LPG gas. It has 55,000, right? It has high calorific value, right? Therefore, we use in our home, right? So and the difference is petrol, kerosene, those are the liquid fuels, but LPG, CNG, biogas, those hydrogen, those are the those things is that fuel that the gaseous fuel, right? This is in gaseous form, and kerosene, petrols in diesel in liquid form, and wood, coal, those are the things in solid form, right? We don't need those things, but you can see when we move to the solid to that gaseous form, that calorific value will increasing, right? But not in the biogas hydrogen, right? But no, not in the biogas. But we can approximately we can say it is increasing when the fuel is solid. The fuel form is solid to gas. When the fuel form is changing solid to gas, it is gradually increasing. We can say, right? That hydrogen, 1 kilogram hydrogen has 150,000 kilojoule per kilogram, right? So that is the thing. So here in this practical, we are going to determine the calorific value for the LPG gas, right? It is around 55,000. So we will do it and calculate. So our calculation will be our answer will be around 55,000, right? It can go, it can change with within the 1,000 or something, right? So this is what we are doing. So I think you have understood what is calorific value at least, right? So calorific value is just an energy, right? Energy of the fuel, right? Of the 1 kilogram fuel, right? Which have inside as chemical energy, right? But when we are measuring, we have to burn it, and somehow we have to by burning the fuel, we have to measure that energy, right? How much energy is converted as heat energy, right? Somehow we have to absorb the heat energy, and we have to measure that heat energy. Then only we can understand, we can calculate the calorific value for that fuel, right? If we take LP gas, we have to, by burning the LP gas, we have to somehow we have to manage to calculate that heat energy that produced by the LP gas. And if we if we can't calculate, we can understand, we can calculate the calorific value. So we have to calculate, we have to calculate the energy by burning the LP gas. We have to calculate the energy produced by the fuel, right? So that we are going to use this apparatus, right? This is our apparatus, right? This is our experiment setup. So in here, you can see this in the gas pressure regulator, there will be a gas meter. This is directly connected with the LPG gas cylinder, right? Gas cylinder, right? Like a home, right? I will show it to you later. I'll show it in a video. So before that, I will explain briefly, right? So this gas through this gas meter, that the LPG gas will be flow to the furnace. This is a furnace setup, right? In the left side, right? This is the furnace setup. But when it is like our home, right? Like gas cooker or something, right? So but we are measuring here that the gas meter is different. We are measuring the flow rate or the volume that going through this gas meter. We have to measure the gas, right, supply to the furnace. And when we burn this gas inside the furnace, then there will be heat, no? Then somehow we have to manage to calculate the heat, right, produced by this gas, right, the burning gas. So therefore we have inside this furnace, we have the water supply, right? There will be a pipes, right? That what the copper pipes uh, which have that inlet and outlet. So through those copper pipe, we will supply the water constantly, right? Continuously, we will supply the water, right? So that water will be flow to the inside of the furnace, and it will gradually flow the surrounding of that uh, the burning gas, and it will absorb that water will be absorbed that heat and heat produced by the gas, right? There will be heat, no, when we burn that the LPG gas, that heat will be absorbed by the water, right? Then later that water will be come in different place, right? This water outlet, then that water outlet water will be exit to the waste, or if we want to calculate collect the water, then we can collect it in a different bucket or something, right? So then you can see this water, we assume there will be, this is a furnace, as it is a furnace, we don't have any it is isolated, no? This is sealed, no? So heat sealed, so therefore there will be no heat losses. We assume there will be no heat transfer to the surrounding or to the environment. So that heat which produced by burning this LPG gas should absorb by the water, right? We assume should absorb by the water. So then there will be a temperature, there will be a temperature that increase, right, in water, right? You can absorb, because in the inlet there will be the water in room temperature. We are supplying from the our tap, right? So that will be room temperature. Water will be go inside in room temperature, but after absorb the heat, the water will become that water temperature will be higher than the inlet temperature. So if you know the different the temperature of water difference, right? Temperature difference of the water inlet and outlet, and we know that density of the water, and we know the water flow rate, or if we calculate the water, some amount of volume of water, and we can convert that volume of water into mass of water, then we can absorb, right? We can calculate the, we know that the temperature difference that happened to the water, right? So if you know the water flow rate, or if you know the water, that volume of water in for the certain time, we can calculate the energy absorbed by the water. So that energy is produced by this, by burning LPG gas. So that's how we will manage to determine the calorific value of this LPG gas, right? So there will be a small calculation. I will explain it later, and also we have videos. In the video, by playing the video, I will explain it to you. And we have observation data I have collected. So in here, the symbol, the thing is, just we have to, after steady state, there will be no change, right? Water will flow steadily, right? But inlet and outlet temperature will be different, right? In outlet will be high, outlet temperature will be high. So and water will be constantly flow. So when we start to collect the water, here we have to start to measure the gas flow, right? That volume of the gas, right? We start to measure, and after collecting 1 liter of water, we can measure the volume of gas that flow through this meter. So we assume that amount of volume of gas, by burning that amount of volume of gas, we can that water that we collected 1 liter, right? That have some energy, no? That have some that collected absorb some energy, no? So that energy is produced by this amount of burning this amount, this volume of gas, right? That's how we will manage to derive this, determine the calorific value. So I will explain it later when we playing the video. So I think you all studied in lectures. I don't know why. So I think before playing the video, I will show you to that observation. Then it will be easy. So this is our observation data, right? What I have done is just collect 1 liter water, right? I have done 2 times, right? So you can take one is enough, right? You can take color, you can calculate calorific value. Again, you can calculate calorific value. Then take that average of those two as calorific value, final value, right? Because there we can reduce the error, right? Therefore, we have done 2 times, right? Same as first I have collected 1 liter. When you start to collect, I am looking that at the meter, right? Gas meter. So when I collect 1 liter water, that gas flow through this gas meter. Gas meter is 2 liter, right? That gas meter you can see. I will show it to you later. If you rotate 1 time, that will be that has volume of gas flowed through this meter is 2 liter, right? So likewise, while collecting the water 1 liter, we can calculate the that burned LPG gas. Volume of the burned LPG gas is 2 liter. So that then we assume that by burning 2 liter LPG gas, that produced energy by burning 2 liter LPG gas will be absorbed by that 1 liter liquid water, right? So that water have some temperature increase now. Water inlet temperature is 36 room temperature, and outlet temperature is 51. So this is a different temperature difference, right? 15. So that 1 liter of water increase the temperature by 15, right? Degrees Celsius, right? For the 1 liter of water, temperature is increased by 15 degrees Celsius. That means that water absorbs some energy. That energy is produced by burning 2 liter of this LPG gas, right? So then we can just putting some, we know the Q is equal to mc into theta or mc into delta t. So using those things, that energy is absorbed by the water is energy is produced by the LPG gas. So we equating the equation, and by using that we can calculate the calorific value of the LPG gas. So in so this is what we are going to, how we are going to measure this calorific value of the LPG gas. So you can see when the second time when we are collecting the 1 liter, it that the volume supplied, the burn volume of LPG gas is 1.9, right? It is, so there will be different values, right, for that, and the other things are same, different value for two set of data. You have to take average as the calorific value of the LPG gas. So we will watch video. So this is our experimental setup, right? This is apparatus, right? You can see this is the furnace that I have discussed, right? This is the furnace. Then in this video I will explain detailedly, and so inside what is inside the furnace and everything. And this is the gas meter, right? So water inlet and outlet. Here how we calculate the water, and this is just a valve, right, to control the supply of the gas, right? So but here using this meter, gaseous meter, a gas meter, we are measuring the volume of the supplied LPG gas.
Okay, this is the voice gas calorimeter, and
The
we are
name of
using
this
this.
apparatus is voice gas calorimeter, right? Because that boys mean that who found this experiment setup, right, to determine this caloric value, right? So that's why to call it as voice gas calorimeter.
We are going to determine the calorific value of the gaseous fuels. So here we are going to determine the calorific value.
You can see this our LPG gas cylinder is connected with the gaseous
for the LP gas. So this is the apparatus. Yeah, using this meter, you can see we can measure the gas flow rate, right?
You can see it is yeah, if it is rotate one full time, that means 2 liters, right? When the gas 2 liters of LPG gas flow through this meter, it will rotate one full rotation, right? So we can be able to measure the volume of that LPG gas, right? So we should know the volume of the gas, how much volume of gas burned, right? Then only we can calculate if you know the density of the gas, we know the density, so we can calculate the how much mass of how much mass of LPG gas burned. So if you know that, then we can calculate the calorific value.
Gas flow rate. If you rotate one times, that means there are 2 liters of LP gas have flowed through this pipe. So after this is a valve, we can close. If you want to, we can fully close, or we can open half or anything, right? By adjusting this, we can. We also can change the flow rate of the gaseous fuel, right? LP gas fuel. So then this LP gas will flow to this furnace, right? So inside this furnace, that LP gas will be burned, right? After burning that LP gas, that heat will be absorbed by the water, right? So here you can see there's a water supply, right? This water supply is already connected with tap. So from this tap we can get the water supply.
Okay. This experiment, this setup is to supply the water with constant pressure and without any air bubbles or anything, right? Therefore, this setup is here, right? So the first with this water will be inlet water will be go through this cup, and then in other all of this cup, this water will flow to the our furnace, right? So that therefore that we can make sure that that water will always flow in the same flow rate, right?
Right, using this setup, this is for to neglect the that air bubbles. So after through this here, after getting water from this line, we will get water without bubbles, air bubbles, to the furnace. So in the furnace there will be copper pipe, which the water will flow around this the burning LP gas, so that the heat will be absorbed by the water. So later there are two thermometers we have to connect here, which is one is in the inlet, right? This is inlet temperature and this is outlet temperature, right? So
You can see
this
this is inlet temperature. This is this thermometer will be used to determine the inlet temperature of the water. This will used to determine the outlet temperature of the water. So this is our supply, right? Inlet water supply. So this will go down and there will be a copper copper pipes, right, around that burning setup of that LPG gas, right? So that through when this water flow through the copper pipes, it will absorb, right? While burning this LPG gas, the water will flow through this inside this furnace and then absorb heat energy and came into this from this exit. This water will be going to the waistline, or if you want to calculate, it will going to the calculated our bucket, right? So you can see this thermometer will be used to determine the outlet temperature of the water. This will be indicate the inlet temperature of the water. So we can, by using those thermometers, we can determine, we can calculate the temperature difference, right? So when we start this one, that outlet temperature will be continuously increasing, right? So after some, when we let give some times, so then it will, then after some time it will remain in same position, right? That means it came to the steady state, right? Came to the steady state. After that only we can start to do the practical, right? So that we have to give some time. Now I will show you to what is inside that furnace, right?
water will be going to the inlet, going from this inlet and absorb the heat which produced by burning the LP gas. Then it will come up through this exit, right, outlet. So here we will measure the outlet temperature of the water. Then also we can, to find out the water flow rate, we can, using this valve, right, we can collect we start to collect the, when we start, we can start to collect the water. Then if we measure the time for certain collected water, we can calculate the water flow rate through this furnace. So, and we know that inlet and outlet temperature of this water. Then we can calculate the energy which is absorbed by the water. We can calculate. From using that, we can calculate the calorific value of the LP gas, right? So we will look what is inside this furnace. Okay, let's see what is inside this furnace, right? Can you see here where this LP gas will be burned, right? Then after burning that gas, you can see downside of this
Inside you can see there's a copper line,
this
right?
furnace, you can see there's a
Copper pipe,
pipe, right?
right?
Which the water will
Water is flow
flow
through those
all the way
pipes,
through
right?
that pipe. So it will, by burning, when the LP gas burn, it will, the water will be absorb the heat,
Right?
right?
And this is insulated. Heat is insulated, right? This furnace, this wall is insulated. So the heat produced by burning this LP gas should be absorbed by the water, right? There will be no way to flow heat from here to anywhere outside. So we assume that the whole heat which is produced by burning LP gas absorbed by the water. That is how we measure the calculate the calorifically of the LP gas here, right?
This is insulated, so heat will not be, we can assume heat will not be transferred to the surrounding. So first we will start the fire. For that we have already connected the pipe with the LP gas cylinder. So here we have the gas meter to measure the flow rate of the gas. Then we will little open up this valve, right? Then you can see this now this meter is moving. Now this meter is moving. If you rotate one time, full time, that means 2 liters of LP gas have flowed through this pipe. So now we have opened. Now we will start the fire, right? Right? Can you see inside? I think you can see now. Now it is burning now.
You can see
right?
this
So
that
it is now.
our LP gas which we supplied through this gas meter is burning here, right? So this is our experiment setup. What is inside this furnace, right? I think you all understood. So while burning his has here, so that, when we supply water around this fire, what is happening is that heat will be absorbed by the water. Then water temperature will be increased and came into the outside. So that's how we will calculate the energy which is produced by the gas, right? Burning gas.
It is burning. So now we have to close this furnace, and we have to give some time to absorb this water heat from heat from this this fire, right? Right. If you let some time, you can see water inlet and outlet temperature will be changed.
Now with the both temperature, initially both temperature is same. It is 36 degrees Celsius. Now you can see now it is not steady state now. So it is now the outlet temperature now it is going to increase and came to a steady state position, right?
That outlet temperature will be increased, right? Now it is 36, 37, but inlet is 36, right? Then that outlet temperature will be increased further, right? So we have to give some time to absorb the heat energy from the fire to the water, right? Now you can see it is increasing now. That outlet temperature is now reaching up to 40 degrees Celsius. So we will let some time, and after when the temperature outlet temperature is become steady, then we can start to collect the uh, water in a certain time period. Let's say for 2 minutes, how much water we can collect, and at the same time we have to measure the flow rate of the gas.
Right. But in this practical, we are going to collect the 1 liter. We are not going to collect in time period, but we are going to collect 1 liter. And while collecting the 1 liter water, we are going to look what is how much volume, right? How much volume of gas gone through this meter, gas meter, so that we can assume that much of volume by burning that much volume gas is the energy that absorbed by the water, 1 liter water is equal to the energy of energy which produced by burning that volume of the gas, right? That is how we are going to do this practical. So let's see our recording. This is our observation.
Okay, now here our observation is to collect 1 liter, right? While collecting 1 liter, we have to observe this how much gas flow, right, through this, and also water inlet temperature, water outlet temperature, right? But what is so we will start the practical, and here we have to start, right?
Now I started to collect
Right.
the water, right?
I started
But when it
at
start the
here,
water,
right?
it is
Exactly here. So
the meter. The
when we
meter
reach
is
1 liter,
0,
we can
right? When we collect 1 liter, exact 1 liter water, we have to find out where this meter is, so that we can calculate the while collecting 1 liter of water, we can calculate the volume of gas flow through this meter, or volume of gas burned inside the furnace. That is equal to volume of gas flow through this meter, right? So while collecting, we had to look into this meter. When the volume of water collected become collecting water become 1 liter, we had to look into this meter, right?
here also we can measure how much the gas is burned at the same time, right? So we can take that 1 liter that the burning has, that much how much energy that has produced, that will be absorbed by the water, right? And inlet and outlet temperature already we can see.
Now it is we are collecting in the steady state, so we don't need to worry about the inlet and outlet temperature, right? That will not be changed anymore, right? So what we are going to do is we have to measure we have to collect exactly 1 liter and measure how much that volume of gas burned in that collecting 1 liter of water, right? Then we assume that much that 1 liter of water have some water absorb some energy. That energy is equal to that amount of volume of gas produced by burning, right? So from that we can calculate the calorific value.
Now we are collecting. Here we can see inlet and outlet temperature. It won't change, right? After a steady state, you can see inlet temperature is 36, but outlet temperature, is 51, right? It won't change. So we can write to collect 1 liter, right? Volume of water, gas we have to calculate and temperature, inlet temperature is 36, outlet temperature is 51, right? Here we can calculate, yeah, right? So but here we have to, right, wait until the gas, the water is become to 1 liter, right?
Right? It is when it is that the surface of the water moving, it is difficult to point out that the position of exactly 1 liter. So therefore, I have done. I have approximately I have done, and I have observed how much is the volume of mm, that gas we burned, right, at this collecting 1 liter of water. And again I have done for up to 200,000, right? That means 2000, that means 2 liters, again 1 liter more, right? So that we can take average, right? Therefore two lines, therefore that two observation right there, so that you can we can take average as the as a calorific value.
Right, now it is 1 liter. This is how much exactly? Around 2 liter.
Around 2 liter, I saw. So I assume it is 2 liter, right? So for one, when we collect 1 liter water, that burning to that absorb the heat absorbed by the water, 1 liter of water, which produced by burning 2 liter of gas, right? So by burning 2 liter of gas, how much heat produced that absorbed by the that 1 liter of water, right? We assume, right?
2 liter, right? 2 liter. Okay.
So again, I did.
Again, we can, if you want, we can calculate one more time, but we don't need. I think. Uh, let's do up to 2000, right? Up to 2 liter. Again, you have to wait, and you can see. That water surface is not smooth or not, it is fluctuating, so that is difficult to see that exact position. So we will do it for 200, right? 2 liters again. It is approximately yeah, exactly 2 liters of yeah, when we are collecting 1 liter water, it is 2 liters of LPG gas is burning. Now we will see, right? Still now there is something, right? This is yeah, 1.9. Okay, 1.9. 9 liter. Okay, now
So we can't hear you.
Sorry. Okay. In this observation data, by using this data, you can calculate the calorific values. Okay. So now you are going to calculate calorific value in your own, right? Everyone you have to calculate, and I ask randomly. You have to tell me, right? For first set of data, only first setup, right? Right. Only for the first row data, right? Which is 1 liter of water, right? When we collect 1 liter of water, it absorbed some energy, right? Heat energy. That way it is temperature is increased, right, by 15 degrees Celsius. That means that 1 liter of water absorbed some energy. Then where did that energy come from? That energy is produced by burning 2 liter of that our LPG gas, right? So when we burning 2 liter of LPG gas, that energy is absorbed by the 1 liter of water. So that water temperature is increased by 15 degrees Celsius. Right? This is what happened. So in this first set of data, in second set of data, there will be a small change. So for each case, you have to calculate the calorific value and take average as final calorific value of the LPG gas. So density of water 1000, density of gas 0.28, right? Not 22. So in your lab sheet, I think there will be printed as 0.22. So you can use it as 0.28, right? This is the exact correct value. So density of the LPG gas is 0.28. And the specific heat of water, right? C, right? In Q is equal to mc theta or mc into delta T, right? In this equation, this is the equation which we use to calculate the heat absorbed by the water, right? If you know the word temperature increment, if you know the water specific water, right? And if you know the mass of the water, right? If you know the 1 liter, if you know the volume is 1 liter, if you know the density, we can calculate the mass m, right? And we know the C, for the specific heat of the water, that is 4.186, but it is in kilojoule, right? You have to remember, right? And the delta T is 15, right? 15. So you can calculate the Q, right? That means that Q is absorbed, which how much energy absorbed by this 1 liter of water. That is equal to how much energy produced by burning this 2 liter of LPG gas, right? Then if you know if you know the volume of if you find out Q, then to find out calorific value, what you have to do? If you know that mass of this volume of this LPG gas, just you have to divide the mass of the LPG gas by Q, right? Then you will get the calorific value, right? Then how you can calculate the mass of this LPG gas? Because if you know the volume, 2 liter, right? So you have to make it as meter cube, volume as meter cube. Then you have to multiply by the density. Then you will get the mass of the this amount of volume of the LPG gas, right? So you have to find out those things and find out what is the calorific value in kilo calorie per kilogram. That means kilojoule per kilogram, right? It is better to megajoule per kilogram. You can put it as megajoule, or if you want, you can calculate it kilojoule per kilogram. So okay, can you do it? I will give 5 minutes to do this calculation. I explain how you want to do. Just do it in your you have some papers and pens in where you are, right? I think so. Just do it and tell me someone what is the calorific value. Then we can move to the discussion part and we can wind up our session, right? And at the same time, who are understood, do the calculation. If you have any clarification, you can ask, right? I will give you 5 minutes, right? Then I will ask the randomly, so you should do, right? So this is our I will keep this display so that you can use this densities and this everything, this observation data. Just do your calculation. Okay. Right. If you who is going to tell me the calorific value, right? First, right? Then you will get some benefit, right, in your lab report. Okay. So let's see who is going to calculate and tell me that value of the calorific. I have already calculated, so I know that value. So let's see. This is a small calculation. Just if you don't if you understood, just clear. Then it's clear, right? Let's see who is going to tell me, right? If someone don't understood this calculation, please you can ask, right? Others who understood, you can do the calculation and tell me what is the answer, right? With the index number, right? the thing is, first you have to calculate this, the volume, right? Volume are in liters now. Then you have to convert into meter cube, right? Because everything in meter cube now, essentially. So just to convert the meter cube, what you have to do is just you have to multiply by the 10 to the power minus 3, right? 1 liter mean 1 into 10 to the power minus 3 meter cube, right? And just replace it and get the Q, right? How much energy absorbed by the water, or in other words, how much energy is produced by burning this this amount of gas, right?